Okay, let's continue our conversation about paper 2 solutions, and we are looking now into question 4b. So 4a has been done in the previous video, and so we'll look at 4b. Find the exact value of k. As you can see, it is just 1 mark question, so should be really easy. Therefore, let's see how we are going to use it. Our previous solution. So in our previous solution, we have seen that the center of the circle we found would be at 6 minus 5, and the radius is square root of 61. So on this circle, I'm going to show the center here, 6 minus 5, and I'm going to show the radius, square root of 61. Okay, and then what I've been told for the part B is that the straight line with equation y equals k, where k is a positive constant, is a tangent to C at the point P. So we have a tangent at the point P, and the equation of the line is y equals k. Equation of the line y equals k is the horizontal line parallel to the x-axis, so therefore it is the only position of this line is going to be here, and the point of where the tangent touches the circle will be here, point P. Okay, and as you can see from 1 mark, it should be pretty easy question, so you don't really need to solve an equation or to make very complex calculations. If it is 1 mark, so it is basically unconditional mark, and you can answer this question pretty quickly. Let's see into our diagram. And so what we can see that the center of the circle will be at 6 horizontally x, and 5 units down at minus 5, right? So if I will start here from the center of the circle at minus 5, and I'm rising up to the point P, I need to add square root of 61, which is the radius, to my minus 5. So therefore, the value of k, y equals, will be minus 5 plus root of 61. Look at the diagram, okay? This is minus 5, and you add square root of 61, and you come to where? To minus 5 plus root of 61. Okay, so that's why k has to be that line. Now we have a very, very interesting question, part C. It was really, really poorly answered. Most of you haven't done. I think just a couple of people have done this question. So let's look at this and see whether you now understand how easy this question was really. Okay, find the area of the triangle OPQ. Okay, what is the Q? Is that the point Q is where the line C meets the y-axis at the origin. So the line C meets the y-axis at the origin here and at another point Q. Okay, so that is the only other point that where the curve C meets the y-axis. Those 2 points, we need to find this point. And so guys, it was a shame to see that most of you even didn't start looking into this question, when in fact at least you could find the coordinates of the point Q. All right, and maybe from there you could still figure out the area of the triangle OPQ. So, but first we need to know everything about the point Q. And what we know about the point Q, that the x-coordinate of this point is 0, and we need to find y. Okay, so if we'll substitute x equals 0 into the equation that we have found, okay, so we can find y, or you can substitute x equals 0 straight into the equation that was given. You still will be able to solve it. In fact, in my opinion, it's even easier to substitute x equals 0 into the equation of was given, or in the equation that you figured out in part A. It doesn't matter really. So if we substitute when x equals 0, then our equation will be 0 squared plus y squared minus 12 times 0 plus 10y equals 0. And all of these things are zeros, and so we'll have y squared plus 10y equals 0. And we'll factorize it, okay? We'll factorize it, y plus 10 equals 0. So y would be equal to 0, or y plus 10 would be 0. And so y2 would be negative 10. And so as you can see, all right, as you can see, we found two values of y. One is 0 and another is 1 minus 10. The first one corresponds exactly to the origin, and the second one corresponds to our point Q. So Q is at minus 10. So therefore, this side of the triangle OPQ is 10. We need now to find the area of this triangle. The area of this triangle can be found really easy using GCSE geometry. To find the area of the triangle, we need half base times height. If my base would be OQ, which is 10, then my perpendicular height will be just 6. Can you see? That is the 6 is the same as the radius of the circle, okay? So therefore, to find our area, we have half multiplied by the base 10 multiplied by the height 6. All right, that is because the height would be 6, and so that is maybe the difficult point was that you are not used to see the triangles where the height is outside of the triangle. The height is perpendicular that you drop from the vertex to the base, and it can sometimes be outside of the triangle. And so I think that's why you could not solve it, okay? So half times 10 times 6 would be 30, and that is 30 units squared. And that is the end of this question. And let's move on to the next one. Okay, question 5 now. In question 5, you need to find the stationary point in part A. So therefore, of course, we will be finding the derivative. Could you please be careful? In order to find the derivative, we had to do some preparatory preparations. So we would write the fraction 8 over x minus 5 in the index form. Then we would factorize it. So both of these expressions would be correct. At this point, you will be getting M1 and A1 for accuracy. And then we would find the stationary point at x equals 0. So we say at x equals 0, dy by dx equals 0. Guys, you have to state this absolutely explicitly to the examiner. If you are not, you are losing marks here. And even if, say, on one or another question, sometimes there is no specific indication that you are losing marks. On other questions, you clearly losing marks. All right, so could you please, from my 8 years experience of marking A-level exam papers, I can tell you definitely, please be explicit in every single thing. Quote the equation, show your knowledge, and then proceed. It also helps you with working memory. If you see in front of you the equation that you're trying to work with, it's actually much easier to avoid any mistakes, okay? So then I substitute my derivative into this equation, and then I substitute x equals 3. So therefore, I find that k will have to be minus 8. And guys, you can't, you have to be very explicit in your calculations. It is the given answer. They gave you the answer. They said that k is minus 8. Those questions are marked very, very harshly. Okay, that means you have to be absolutely clear about every single calculations. You can't jump from here straight to there because that is the given answer. You need to show the full logical step. How did you come to k equals minus 8? So you can't skip even 6 plus k plus 2 because otherwise there will be no marks. All right, so that's it with part 5a. Part 5b, determine the nature of stationary point. So at this stage, I just simply will show you here. So shows stationary, the nature of the stationary point, you have to find the second derivative. That is what it is. When x equals 3, I will be talking very faster now. So, but you can always pause the video and look a little bit more carefully. All right, so at x equals 3, we find that the second derivative is positive. Therefore, stationary point at P is a local minimum, since the second derivative at x equals 3 is positive. Could you please pay attention how you answer the questions? Could you? That is very serious exam. All right, and so could you please don't be too proud to write too little, okay? Write down everything in very detail. What is your answer and why that is the answer, okay? Right. Question 5c. Show that the curve has a point of inflection where x equals 7. So when x equals 7, we find the second derivative, okay? And what I'm doing here, there will lots of lost marks because many of you have done one criteria but not the second criteria. So could you please be careful and revise better this points of inflection wasn't really revised well by most of you. That is where you need to go back to the textbook and do more practice. So what I have done here, I'm looking into the second derivative, and I'm saying like see that at x equals 7, the second derivative is equal to 0. And then I'm looking into the second derivative slightly before 7 and slightly after the 7. And I see there is a change of sign, okay? So I see that at before 7, the second derivative is negative, and after 7, it's positive. So at x equals 7, the second derivative at 7 is equal to 0. So, and the second derivative has different signs on either side of x equals 7. Therefore, x equals 7 is the point of inflection. All right. So there should be two things needs to be done. This one, that's criteria 1 and criteria 2. And 5D now. Explain what the error Jane has made. So, so as you can see, look, the curve passes through this point, and look carefully at the points that she's picking up, 4.5 and 5.5, and look at the function. All right. Most of you didn't answer the question well, so could you please look? Okay, so in the very good answer, sign change method is not valid because the curve is not continuous over the interval 4.5 to 5.5. That is the correct answer, okay? So as you can see, the function doesn't exist at x equals 5. Therefore, the function is not continuous in this interval, and the sign of change method is not going to work for in this interval. All right? So that was question 5. Question 6 now. Question 6, we need to use the factor theorem. So you substitute f at 3, and you need to show all calculations. Again, it is the given answer. Don't take it easy. You have to show all of this. You can't say that, oh, I've got calculator. All right, so I've got it on my calculator. They ask you to show, so do show them every value here. And then f at 3 equals 0, therefore x minus 3 is a factor of f of x. By the factor theorem, you need to write the conclusion in full sentences with all what and was all whys and all detailed reasons. 6b. Given that f of x is x minus 3 squared times x plus a squared, deduce the value of a. So deduce the value of a. If a is equal to 2, can be found, or a equals to 2 can be found by using the factor theorem for various x's until a equals to is found. So some of you found a equals 2 by simply trying on calculator until you found, and you can also find by simply dividing the polynomial, the original polynomial, by x minus 3 squared extended. So I have done both of them, and so I have found that if you divide this polynomial by this quadratic, so you will get x squared plus 4x plus 4, which is x plus 2 squared, and that's why a equals 2. All right. So what else needs to be done here? So we need to sketch the graph somewhere. So we'll sketch the graph. Okay, we'll sketch in the graph here. Okay. So let's look at 6c. So we've got this function here. So, and we try to investigate this function a little bit. So we say when x equals 0, so we need to find where the graph will cross the x-axis and the y-axis. So when the graph crosses the y-axis, x will be 0. So that's why we first try x equals 0, and we substitute x equals 0 into the formula, and we find y equals 36. So the point where our graph, that's our future graph that we will draw, crosses the y-axis will be the point 0, 36. And then we need to find the point where the graph will cross the x-axis. So when y equals 0, we solve this equation, we find 2 points, and we see that the points will have to be -2, okay, -2 and 3. All right, and then you know the value, okay, and you know how the graph should look like. And what I would like just to point out that you need to ensure that you show this maximum, the maximum at the first quadrant. It's not symmetrical. Those of you who did show this as symmetrical, you will lose the marks. The reason for that, because the distance from 0 to this point to 3 is 3 units, when the distance here is 2 units. So therefore your maximum is somewhere here after the y-axis, all right? And there was 1 mark for that. So you're getting 1 mark for the correct shape. Then 2 minimum points at -2, 0 and 3, 0 needs to be plotted. Then 1 mark for showing the y-intercept. And finally, there was also, they considered that that maximum has to be at the first quadrant, and when it wasn't, you were losing 1 mark. All right, please be careful. Question 7. We have a function, 2 functions here. We need to find the finite region R. So we obviously, we need to know from, we know that we will need to integrate from 0, but to what? To this point, right? So in order to find the coordinates of this point, we see that these 2 graphs intercept each other. So therefore, at this point, our y's are the same. So that's why I equalized y equals kx squared with y equals square root of kx. I equalized them, and then I solved this equation. So you can pause the video and look into more detail and to see all the steps and how I've got finally my solutions. One is x equals 0, and another one is x equals cubic root of 1 over k, or k to the power of -1 over 3. Could you please look at what has happened, okay? And after this, we start integrating. And we're integrating function square root of kx minus kx squared from 0 to k to the power -1/3. Okay, I wrote in more convenient way k to the power -1/3. I just eliminated square root of k, so then we integrated. And then when we integrated, could you please make sure that you explicitly you show the correct use of limits? Many times when I was marking with Pearson in the exam papers, I have seen always people losing marks for not showing limits correctly. You need to show your substitution, and you need to show that you substituted 0 correctly and what you subtracted from. And then we get the answer and we prove it as that will be equal to 1/3 as required. Okay, right. Question 8. Find in terms of a and b the first derivative, the second derivative. So that is the first derivative, and this is second derivative. Pretty forward, right? and then A to B, and we have condition, we have the point P, and we have the second derivative equals 0 at P. We need to find the values of A and B. So we have our x equals 3 over 2, y equals 13 over 2, and we basically substitute our x and y's into the derivative that we have found. No. We substituted that, okay, into the equation of the curve. So can you see here the equation of the curve, right? So we substituted x with 3 over 2 and y with 13 over 2. We substituted, all right? And so we have found this equation, and then we simplified that further, and that's what we received, okay? And then we would substitute, we will look into another equation where this all coming from. 9a plus 2b. Okay, 9a plus 2b. So we substitute into the first equation, then we need to find the second equation. So yeah, we will choose the second derivative equation. All right, we will choose the second derivative equation. We've been told that it is equal to 0. So we substitute 6a times 3 over 2 plus 2b equals 0. And we substitute, well, I feel I already don't remember what I've been doing here. Just a second. Okay. All right, so here we are. So look back into this equation that I have done. I just have done this paper some time ago and writing video after, so I just slightly forgot, okay? So what I have done here, I used the equation of the curve and I substituted x equals 3 over 2 and y equals 13 over 2 into the equation of the curve. And then I substituted the x value and y value into the second derivative, which has to be equal to 0. So I've got equation 1 and equation 2. And then what I have done, I just simply simplified all of this, okay? Look into my solution. See how I simplified. Okay, and I solved simultaneous equations, and I've got a equals 2 and b equals minus 9. Please pause the video and look how it was found. All right. So question C, we need to show that P is the point of inflection. So we do a few things. We need to show that the P is the point of inflection. All right, so therefore we find the second derivative now with a and b. We substitute the values of a and b into the second derivative. We get the equation 12x minus 18. So, and then we say, well, at x equals 3 over 2, because our point is P has these coordinates, the second derivative, if we substitute, will be equal to 0. So criteria number 1 is completed. Let's check criteria number 2. Let's find the values of the second derivative slightly before x equals 3 over 2 and then slightly after. So I have found the second derivative at x equals 1 and then at x equals 2. And you can see there is a change of sign. Hence, x equals 3 over 2 is the point of inflection. So hence the x equals 3 over 2 is the point of inflection because there is a change of sign slightly before and slightly after, and the second derivative is equal to 0. So most of you have done only one test, but you forgot about the second test, and you have to do it, okay? Because the point of inflection maybe not necessarily the point of inflection, can be minimum, maximum, okay? There is another test that you could do, all right? So you could find the next derivative, the third derivative, and to see whether it is equal to 0. All right, so if it is equal to 0, because it's not equal to 0, if it would be minimum maximum, then the next derivative would be also 0. But since the next derivative is not 0, it's 12, since that's the point, 3/2 is the point of inflection. Okay, now trigonometry. Trigonometry needs to be proven here, so could you please pause the video and see what I have done here. Look at the double angles and see what I need to come to. I need to come to tangent with the single angle. So therefore, sine 2 theta will be equal to 2 sine theta cos theta. Cos 2 theta will be 2 cos squared theta minus 1. So cancel and factorize and divide by common factors, and we receive tangent as required. And then now we need to solve the equation. Okay, so solving this equation, we transform the left side to tangent, and then tangent is sine over cos. I multiply by cos both sides, so sine x will be equal to 2 cos squared x, and cos squared x can be written in terms of sine, and therefore after this, alright, after this, I'm getting quadratic equation that needs to be solved, and so I'm getting two values of sine x, and so, and after this I solved for x. Please pause the video, look carefully into the solution. Alright, so now question 10. Alright, question 10. Again, we need to show that this equation can be equal to k cosec x, where k is constant to be found. Right, so we need to show that the left side comes to cosec x multiplied by a multiplier that needs to be found. So long story short, take the left side and transform to cosec x. Could you just pause the video? Look what has been done. See the fractions with different denominators. So we combine the denominators. We made the necessary transformations. Look what was happening here. I raised to the power of 2. Sine squared plus cos squared is 1. So 1 plus 1 minus 2 cos x would be equal to 2 minus 2 cos x. Factorize. Divide by common factors. And you get 2 over sine x. But 1 over sine x is cosec x. So k will have to be equal to 2. Alright, so then they're saying, hence explain why this equation equals 1.6 has no real solutions. Okay, simple. 2 cosec x is 1.6, so cosec x equals 0.8. As cosec x is undefined for in this interval, then the given equation has no real solution. So cosec x has no real solution in this equation, and what you received in the given equation, that cosec x is equal to exactly 0.8, that's why it has no solution. There is another way how you can think of this, okay? That is another way to think about this. 2 cosec x equals 1.6, but cosec x is 1 over sine x, so that means that sine x will be equal to 1.25. As sine x is only defined between minus 1 and 1, then the given equation has no real solutions. That's another way to approach the question. Question 11. Quite a few mistakes about logs to be used wrongly. For example, could you please be careful, okay? Could you remember that log of a plus b is not equal to log a plus log b? Right, that is a really serious mistake. Could you please, if you think so, okay, could you please go back to, I even don't want you to see it, okay, I don't want you to remember any of this, but some of you have been making such mistakes. That's the only reason for those people who could not achieve a mark here, okay? So we need to find, to solve this logs equation. So could you please pause the video, look carefully through the entire process. Okay, and let's start. So we have 2 logs of x plus 3 to the base 6. I'm taking 2 inside of log, and then I'm bringing log to the base 6 to the left side, and then because I'm adding 2 logs together, I multiply the expressions under the log, so therefore that expression will be equal 6 to the power of 2 equals 36. X plus 3 squared equals will be x squared plus 6x plus 9. Alright, and then open the brackets, simplify, factorize, and get the solutions. And then x minus 5 has to be rejected. Could you please see why? Right, x equals minus 5 has to be rejected. So don't forget to do it, because otherwise you will lose, of course, marks if you are not doing this, if you're not careful with logs, okay? Okay, question 12. Nearly done. So question 12, sketch the graphs. I'm doing first the equation y equals 2x minus 9. Okay, and then I have done reflection. So that is the first part. That is y equals 2x minus 9 first drawn. Then I have done modulus, so I reflected in the x-axis. And then I raised this graph 3 units up. So that's why you see what you see. And I would like to show you that, tell you that you need to have the point, the point where you the graph is bended, and then also you need to have the point of all the points of intersections with the x and y axis, if there are any. Okay. Part B, we need to solve the equation. 3x plus 1 intersects with the y equals minus 2x plus 9 plus 3 branch of the function. We need to solve the equation, this equation. Alright, so therefore x will be equal to 11 over 5. Again, pause the video, look a little bit more carefully. Alright. Okay, that was 12b. And now we'll look into 12c. 12c. The question on 12c was, find the range of possible values of k. Okay. The lines do not meet when k more or equal than minus 2. So the biggest possible k is when the line touches the graph of the function at its vertex. Alright, could you please see the graph? And I hope it makes sense. Okay, the biggest possible k is when the line touches the graph of the function at its vertex. So therefore, we have to solve this equation. So k equals 4 over 9, and that means that k will have to be more or equal than minus 2, but also less than 4 over 9. Okay. Please look into that question again and check with us if something not clear. The next question was pretty basic vector questions. All right. So 13a. So AB squared would be equal to, so I'm finding AB squared using the cosine rule, or the modulus of A or A is found using the Pythagoras. And so therefore AB squared will be equal to 5 squared plus 10 squared minus 2 times 5 times 10 equals 60 degrees, which is 75. And then we find the length of AB is just simply square rooting. Okay, simply square rooting, and that's the answer. 13b, we need to find OB, and we need to find the value of P. So could you please look? All right, BA is 4 roots of 3i plus PJ. All right, but AB squared is equal then 4 square root of 3 squared plus P squared, which is also equal to 5 roots of 3 squared. 5 roots of 3 squared from part A. Alright, and so then just solve the equation and you will find the value of P. End the story. There is a little bit more, okay, because we need to write OB. Okay, OB is OA plus AB, add two vectors, simplify, and that's your answer. Alright? That's your answer. Nearly done. So finally, question 14. I think it's not finally actually. So 14a. Alright, 14a. We need to find, we have the curve has a minimum turning point at P and a maximum turning point at Q as shown in figure 5. Show that the x-coordinate of P and the x-coordinate of Q are solutions of the equation cos 2x equals 1/3. Alright, so 14a. Okay, we have this function f of x sine 2x over. Alright, and we need to show that the curve has a minimum turning point at P. Because we need to find the minimum point, so we obviously will be finding df by dx. And what you see here quotient, and we need to differentiate this function f. So I'm writing f of x as u over v. U will be sine 2x and v minus 3 plus cos 2x. I find du by dx and dv by dx. Okay, can you see it all? Alright. And then let's see what it comes to. Could you pause the video? You know that I applied the formula and then I equalized the first derivative to 0, and the fraction is equal to 0 only when the numerator is equal to 0. And then I open the brackets, collect like terms, and I come to the equation cos 2x equals 1/3. That is exactly what we needed to show. Alright, then 14b. Okay, in 14b, we need to find the x-coordinate of the maximum turning point on the curve with equation f at 3x plus 5. Alright, so if f so f at 3x would be equal to f at 3x plus 5 will be equal to, if z equals 3x, let's find dy by dx. So dy by dx will be equal to df by dz times dz by dx. And so all I wanted just to show you what dy by dx, if dy by dx is equal to 0, so that will be the same as df by dz will be equal to 0 here, right? And so we solve that equation. Just a second, let me just remember the question again. So the x-coordinate of P and coordinate of Q are solution of this equation. So they say hence find the x-coordinate of the maximum turning point on the curve with this equation, f of 3x plus 5. So in order to find, maximum point, so you would do dy by dx, right? But our function is a complex function. So when you differentiate dy by dx, you apply the chain rule. You will get derivative of the function itself multiplied by 3, right? Because when you differentiate 3x, you will get 3. All right. So that means that derivative dy by dx will be equal to actually derivative of the function itself by dz. That's why I'm solving this equation, cos 6x equals 1/3, okay? And so once you solve it, you find all the solutions, okay? And then in the region that was requested, we have only these two solutions, and the first value is for the minimum and the second is for the maximum. So therefore we choose the solution x equals 0.84. Okay, and then in similar way we solve the next equation. So cos half of x equals 1/3. So here I find all the solutions. Please look and try on your calculator. Alright. And then for similar reasons, we find that x equals to 2.46. And finally, final question, 15a. 15a. So we have here binomial, and for binomial is we will need to take 2 out of brackets. So I'm taking 2 out of brackets. Don't forget the power -4. And then we apply the binomial and we solve the equation for the coefficient with the second power. All right, I hope it makes sense. And then you solve the equation and you get k equals 5. And once you found k equals 5, you can find the value of a, and that's what it is. And finally, you need to determine, given a reason for your answer, whether the binomial expansion is valid when x equals 1/10. So you know that binomial expansion will be valid when kx/2 by modulus is less than 1. So therefore, if your k is 5, so therefore that is modulus of 5x/2 is less than 1. That means modulus of x is less than 2/5. And that means that x is somewhere between -2/5 and 2/5. It means x equals 1/10 lies in the interval, and the binomial expansion is valid. And that's it. That's the entire paper. I hope it made sense. If something didn't, could you please come and see us, or maybe just look into this video again and revise and do some practice. Thank you very much for watching this video and working well on your papers. Bye.